Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 2, Lesson 4, Justifying the Steps in Solving an Equation. And I want to just take a moment to apologize for the last couple videos. In this video, I do have a little sinus thing going on, so bear with me. So, properties of equality. And remember, these boxes are good things to write down for your WSQ and understand these properties. So, additive property of equality. If A equals B, then A plus C equals B plus C. You can add or subtract the same quantity from both sides and retain the equality. When you're using just those letters like that, sometimes it's difficult to notice it. So I have a couple of exercises here that demonstrate the additive property. Multiplicative property of equality. A equals B, then C times A equals C times B. You can multiply or divide by the same quantity on both sides and retain the equality. So let's look at exercise number 1. Consider 2x plus 9 equals 21. Step 1 wants to know what property is happening. I highlighted the property in orange, the changes that were happening. So I subtracted 9 on both sides. Notice I did it in orange. Which property is step 1? Hopefully you said that it was the additive property of equality. So let's write in additive. Additive property of equality. Step 2, noticed here that I multiplied by the reciprocal on both sides. So if I multiplied on both sides by the reciprocal, what property do you think it is? It's the multiplicative. Multiplicative. Sorry. Hopefully those two examples will help you understand the properties a little bit better. Okay, that was a reasonably simple two-step equation. Now let's go for the full experience. Exercise number 2. Consider this long equation. As in the last problem, each step of the solution is shown. We're going to write our justifications on the right-hand side. And remember that we have the properties of real numbers to deal with as well from unit number 1. Step 1. I took that 3 and I multiplied it into the x and the 2. I took the negative 2, multiplied it into the x and the 7. That is called that's exemplifying the distributive property. So that you should write in distributive. The second property, step 2, basically all they're showing us is that we're taking my 2x and sliding it over to the left, my 6 and sliding it over to the right, making sure that my like terms are together and my like terms are together. And we're allowed to change order like that because of the commutative property. Step 3, I'm taking the x that's in common in both of these and pulling it out. It's basically showing you the distributive property in reverse form. So it is still considered the distributive property. Step 4 is taking and I'm going to circle it, it's taking this negative 4x and moving it on both sides. I'm balancing it out. The negative 4x is going to cancel that negative 4x out. So when I do that on both sides, that is called the additive property of equality. Step 5, I'm basically just changing the order of things and the way they're written so that the math is easier for me. So that is just the commutative again. Step 6, I'm pulling the x out again so I can do my math. I'm going from right here, I'm pulling that x out so I can do my math and make my math a little easier. So that is called the distributive property. In step 7, I'm showing that I'm dividing by -3 on both sides. As long as it occurs on both sides, I'm keeping everything equal. That is the multiplicative property of equality. Strange things can sometimes happen when you solve an equation. Even if every step is justified, results can turn out confusing. Let's take a look at exercise number 3. Consider the equation 5x minus 3 times x plus 1, which equals 2x plus 4. Find the missing justification in the solution of this equation below. And once again, we're going to write our justifications down the right-hand side. So step number 1 is demonstrating the distributive property. Step 2, if I take this -8 on both sides, and I do it to both sides, that is the additive property. Ooh, let's change my markers real quick. Step 3, I'm pulling that x out again, so therefore it is the distributive property, just kind of reverse looking. Step 4 is an example of the additive property of equality, because I'm doing minus 2x on both sides. And the last property, step 5, I'm changing the order of things on the left-hand side to make it say 2x minus 2x, and that's going to be the commutative property. In exercise number 3, what they're really wanting you to understand and stress is noticing that this is strange, and noticing what happens at the end. Doesn't 2x minus 2x give me 0? It goes away. So really, does -11 equal 0? And the answer in your mind should say, no, it doesn't. So we want to write down for question B, and I have this on the next slide. So let me just hit pause and we'll continue. The final line of the set manipulations is very strange. -11 equals 0. Is this a true statement? No, it's not a true statement. Can any value of x make this statement true? The answer to that is no. No value of x can make this statement true. It's because there is no solution. When you have a problem or an equation that works out to be like exercise number 3, where it says -11 equals 0, or any other circumstance where the numbers do not match up, there is no solution for that problem. It says here, C, what do you think tells you about the solutions to this equation, the values of x that make it true? There are no values that make this true. No values you can write in. Exercise number 4. Consider the following equation. What I want you to do is show that x equals -5 and x equal 2 are both solutions to this equation. So I've taken the time already to plug in the numbers. I took the -5 and plugged it in every time I saw x. So all I have to do is the math. And we can do that together. If you want to hit pause and do it and then check your answer, that's just fine as well. So 7 times -5 gives me a -35. -5 plus 5 gives me 0. 0 times 2 gives me 0. 9 times -5 gives me a -45. Plus 10, it's going to give me a -35 equals -35. Let's go to the right-hand side and continue doing the math. Now I took the 2 and I plugged it in for x every time I saw it. So I'm going to have 14 plus 5 times 2 gives me 14. 9 times 2 gives me 18 plus 10. And all I'm using is PEMDAS to solve this equation on either side, the expressions on either side. 14 plus 14 is 28, equals 18 plus 10, which gives me 28. Now I have one equation two different solutions, and they both work out to give me correct answers. How could that possibly be? Well, let's take a look at B and see what B says. It says, solve the equation by manipulating each side of the equation as we did above. What does its final strange result tell you? So let's go ahead and now let's manipulate this like we have been. We're going to first distribute 2x in, so it's going to give me 7x plus 2x plus 10 equals 9x plus 10. 7 plus 2 is 9x plus 10. If you notice already, you can see in this line, the left side is equal to the right side. Let's continue working it out so I can prove my point. Minus 9x on both sides. Your x's will go away. I'm going to be left with 10 equals 10. When that happens, when this happens, we know that this is a strange result, and it's a special case, and it's called infinite solutions. I want you to test this conclusion. I want you to do C on your own by picking a random integer, really any number, and showing that it is a solution to the equation. I don't care what number you pick. I picked 4. You could pick anything else that you would like and see if it works out and prove that really there's infinite solutions.